In this video, I will discuss a JEE Advanced PYQ from the topic Electrostatics. This question is based on finding the electric potential due to a dipole at a point whose position vector makes an angle theta with the dipole. Dipole is two equivalent opposite point charges Q and minus Q. Q is positive, separated by a small distance 2a. So the potential due to this dipole at this point P, in the middle of the dipole. So that point P has a position vector R with respect to this origin. So this R vector makes an angle theta with the dipole. Dipole vector is defined as a charge Q and the separation between them, and the direction P cap is from the negative charge to the positive charge. So P vector is like this, dipole vector from the negative charge to the positive charge. So this angle theta is between P cap and R cap. This is the direction of R cap. Potential at this point P is given as 1 by 4 pi epsilon naught into P dot R cap by R square. One way to remember this formula is, for a point charge, potential is K, which is 1 by 4 pi epsilon naught, which is a constant, into the point charge by R. So dimensionally it is charge by distance. So dimensionally it is, this has got some dimensions which will be same here also. So other than this K, it has got dimension of charge by distance, and it's also dimensionally equivalent to charge into distance by distance square. P has got dimension of charge into distance. So dimensionally this is equivalent to P by distance square. So that way you can remember this formula. So dimensionally it should be P by R square. For point charge is Q by R, and for dipole it is P by R square. This formula can be derived using superposition principle. Potential at this point P due to the dipole is potential due to this charge Q plus the potential due to the charge minus Q. So this distance will be different from R1, and let this distance of the point P from the negative charge be R2. So potential at this point P is K, which is 1 by 4 pi epsilon naught, which is a constant. Let me assume this thing is in air. So epsilon naught is permittivity of the medium, which is air here, into, this is actually K into P cos theta by R square, because A dot B is A into B into cos of the angle between them. A is P, P is 1 because it's unit vector, and the angle between them is cos theta. So this angle, but for a point charge, it's K into Q by R, so it's Q by R1. Potential to this point P due to this positive charge, and due to the negative charge, it will be K into minus Q. I'll put the minus sign here by the distance R2. So R1 and R2 can be written in terms of R using the cosine rule. R1 square equal to, this is a triangle R1, and this much is A from here to here, and then this R. So R1 square equal to R square plus A square minus 2AR cos theta. So the triangle is A, R and R1, and angle theta is opposite R1. So R1 square equal to R square plus A square minus 2AR cos theta. The theta is angle opposite to R1. This is called cosine rule. For a triangle that can be proved for so the cosine rule can be proved from Pythagoras theorem for a right angle triangle A, B, C. C square equal to A square plus B square. This is Pythagoras theorem. But this cosine rule is for a general triangle. It's not 90 degrees. It's not right angle triangle. So A, B, and C. So this for this triangle, similar to this relation, we have C square. The opposite angle is theta, opposite to C, which is equal to sum of these two squares, A square plus B square minus 2AB cos theta. For a right angle triangle, theta is 90 degrees. So if you put theta to 90 here, this term will go. So you get this Pythagoras theorem. To prove this thing, complete the right angle triangle like this. So this distance from here to here, this length is A, and this is pi minus theta. So this is A cos pi minus theta, and this vertical distance or height is A sine pi minus theta. So we can apply Pythagoras into this bigger triangle. That will give me C square equal to A sine pi minus theta whole square plus B plus A cos pi minus theta from here to here. It's B plus A cos pi minus theta the full square. So this will give me A square sine square, and then A square cos square, that can be combined as A square, and B square will come from here, and then have 2AB cos pi minus theta. Cos pi minus theta is same as cos theta, and the sine, this is in second quadrant, will become minus cos theta. So you'll get this formula. So cosine rule, in some sense, is generalization of the Pythagoras theorem. Cosine rule is for Pythagoras theorem for right angle triangle, cosine rule is for any general triangle. So using Pythagoras theorem, cosine rule can be proved. So this thing can be used to write R1 and R2 in terms of R and the A, half the dipole size. From that we can derive this relation. This derivation is not required for solving the question, but we should have some idea how the formula comes. So with this understanding, we'll solve this JEE advanced question. An electric dipole is formed by two charges, plus q and minus q, located in the xy plane at 0, 2 mm and 0, minus 2 mm, respectively, as shown in the figure. The electric potential at point P 100, 100 mm due to the dipole is V0. The charges plus q and minus q are then moved to the points minus 1, 2 mm and 1, minus 2 mm, respectively. What is the value of the electric potential P due to the new dipole? You can pause and attempt this question. So the formula for potential due to a dipole is 1 by 4 pi epsilon naught into P dot r cap, that will give me P cos theta divided by the distance square. So in the second case, the dipole is tilted, but the distance remains the same. R is same. So this I can combine 1 by 4 pi epsilon naught and 1 by r square, which is same for both the dipoles. Because the distance of the dipole is not changing because the tilting, because the middle point is at the same location. So let me call this constant as k prime, because k is 1 by 4 pi epsilon naught. So it's the same k prime. This is the second dipole P2 and the second angle theta 2. In the first case, the dipole makes this angle theta 1. Second case, the angle of the dipole with the position vector is this one, theta 2. So first case theta 1, second case is theta 2. Okay, so V2 by the first potential is P2 by P1, the dipole vector into cos theta 2 by cos theta 1. And this V is given as V0. So V2 by V0. And then P is the charge into the distance. Charge is same. When the dipole is tilted, the charge is not going to change. But the size of the dipole is changing. First case it's A2. Sorry, in the second case it's A2. First case A1. And then theta 2 is, let me call this angle alpha. So theta 2 is theta 1 plus alpha. And theta 1 is 45 degrees because this point is 100, 100. So I can get this angle like this also. So this angle theta 1 is this 100 by 100. This is actually 45 degree line. Only then x and y will be same. So this angle theta 1 is 45 degrees. And alpha we can find from this triangle. This distance is 1. Magnitude is 1. And this vertical thing is 2. So tan alpha is 1 by, not tan alpha. Yeah, tan alpha is 1 by 2. So this is 1. This vertical thing is 2. So this hypotenuse is square root of 5. It's 1 square plus 2 square. So root 5. And A1 is this from here to here, which is 2. And then A2 is from here to here, which is root 5. Actually, this size of the dipole has increased. It's being tilted, but it's at the same vertical level. So obviously, this thing has to get stretched a little bit. So 2 has become root 5. Root 5 is 2 point something because 2 is square root of 4. This more than 2, which is root 5. So this ratio is root 5 by 2. And then cos theta 1 is 45 degrees. And cos A plus B formula, cos A plus B is cos minus sin. So this we can use here. So this will become cos 45 cos alpha minus sin 45 degrees sin alpha by cos 45 degrees. Theta 1 is 45 degrees. The first case dipole. Okay, so this just has to be simplified. Cos 45 and sin 45 are equal and is equal to root 2. So this will cancel. So it will be just cos alpha minus sin alpha root 5 by 2 into cos alpha minus sin alpha. Cos alpha I can get from the triangle. This is the triangle for cos alpha. So it's this is 1, 2, and hypotenuse is root 5. So cos is 2 by root 5 and sine is 1 by root 5. Sine is less. Sine is 1 by root 5, cos is 2 by root 5. So cos alpha is 2 by root 5 and then sin alpha is 1 by root 5. So root 5 will get cancelled. So it is half. So the potential is reduced to V0 by 2. So this will give me the potential in the second case is the first case potential by 2. Because V2 by V0 is half. So V2 equal to V0 by 2. B is the correct answer. This would explain here. Potential in the first case is K prime P cos theta, P1 and theta 1. And K prime is 1 by 4 pi epsilon naught into 1 by r square, because for the two dipoles, the distance is same because the dipole is tilted about the middle point. So the distance of the dipole to the point is not going to change for the second case. Potential in the second case is same K prime, which is this constant, into P2 cos theta 2. So the ratio will be P2 by P1 into cos theta 2 by cos theta 1. And P is the charge Q into the distance. Charge Q is same in both the cases. So the distance will be A2 in the second case, A1 in the first case. And the angle theta 2 in the second case is 45 plus alpha. Where alpha we can get from the small triangle. First case the theta is 45 degrees. A2 is root 5 by A1. This is root 5. In the first case, A is from here to here, that's 2 mm. Second case is this one. That can be got from the Pythagoras theorem. This is 2 square plus 1 square, because this coordinate is minus 1. So from here to here, it's 1. So 1 square plus 2 square is root 5. So A2 is root 5. Square root of 5. First case, A1 is 2. First case, the A1 is from here to here, 2. Root 5 is slightly more than 2. And cos 45 plus alpha. And tan alpha is half. This angle is alpha. So in the second case, angle is theta 1 plus alpha. Alpha is tan alpha is this opposite side, 1 by 2. And this root 5. So cos alpha is 2 by root 5. And sin alpha is 1 by root 5. Sin is less because this opposite side is smaller. So sin alpha is less 1 by root 5. Cos alpha is 2 by root 5. Simplifying, we get V2 equal to V0 by 2.